जी अस्सलाम वालेकुम. Can you hear me? आवाज आ रही है जी?
Yes, sir.
ओके जी.
Yes, sir.
Okay, let's wait for a minute so that the rest of the people they can also join. And kindly turn off your mics and cameras, please. Okay, ji. So this is the first lecture uh, about the electronic devices and circuit. So the books which we are going to follow, the first book is the first book is electronic devices and circuit theory. Electronic devices and circuit theory by Robert L. Boy listed, right? So this is the major book which we are going to follow, right? Again, any edition, if you get hold of it, it is good and it works fine. Because again, the point is to have the understanding of the things, or rather to have the memorization of the things, right? So this is the book, Electronic Devices and Circuit Theory by Robert L. Boylston. Anyway, we will be following 10th edition. So if you get hold of 10th edition, or there is 11th edition is also available. So if you get hold of 11th edition or 10th edition, both works fine, right? 11th or 10th edition, this is fine. Even 9th edition is also available on net. So if you get hold of any edition, this is fine. Okay, ji. So let's start. What we have basically okay. So let me ask you guys because this is the first lecture. So what is the difference between the conductor, insulator, and semiconductor? Anyone? Anybody? What is the difference between conductor, insulator, and semiconductor? Anyone? कोई idea? कोई कुछ अपने ख्यालात का इजहार करना चाहे?
कंडक्टर्स में इलेक्ट्रॉन की फ्लो होती है और
जो होता है which
Okay, one at a time, please. जी.
कंडक्टर जो होते हैं ना उसमें इलेक्ट्रॉन की फ्लो होती है और जो इंसुलेटर्स होते हैं ना वो इलेक्ट्रॉन की फ्लो अलाउ नहीं करते।
अच्छा जी, ठीक है। और सेमीकंडक्टर में क्या होता है?
सर इसकी कंडक्टिविटी इन बिटवीन कंडक्टर और इंसुलेटर में होती है सर।
वो कंडक्टर
अच्छा,
बन जाते हैं जब हम उसको हीट करते हैं सर।
कंडक्टर बन जाते हैं तो हम उसको हीट करते हैं, वो
मतलब
सेमीकंडक्टर हो जाता है।
तो सर इसकी कंडक्टिविटी इन बिटवीन कंडक्टर और इंसुलेटर में होती है सर। ये
ओके,
ना तो मतलब फुल कंडक्टर होता है और ना ही मतलब इंसुलेटर होता है।
so anyone else who want to put some light on it? जी, anyone else? The difference between conductor, insulator, and semiconductor. Okay, when we take a look of the conductor, so what is happening that as the conductor is material which has got basically, when we go into the structure of the atom of the conductor, insulator, and semiconductor, so what is happening that the conductor in the atom, in its outermost shell, what we have basically free electrons. So if we see the conductor, what is happening that in case of conductor, the outermost shell is normally called the valence shell or valence band, right? And the electrons which are available for the free electrons which are available in case of conductor, they are in the another band which is called the conduction band, right? Now in case of conductor, the valence band and the conduction band, they are actually have, or they are actually overlapping one another, right? So what is happening that anything which is in the electrons which are in the valence band, because the bands they are overlapping, so they are also available in the conduction band, right? Now, in case of insulator, what is happening that in case of insulator, what is happening that the gap between the conduction band and that of the valence band and the conduction band, the gap or the band gap is quite big, right? So due to that, the electrons which are available in the valence band, it is next to impossible to overcome the band gap between that of the conduction band and that of the valence band, right? So even if you provide some external energy, it is very difficult to overcome the band gap in case of insulators. Now, the third thing which I have talked about is basically the semiconductor. Now, the band gap in case of semiconductor is actually in between that of the insulator and that of the conductor, right? So if you see, in case of conductor, they are overlapping one another. In case of insulator, there is a big band gap. But in case of semiconductor, the conduction band and the valence band okay, the band gap between that of the conduction band and valence band is actually in between that of the conductor and the insulator, right? So due to that, what happens that whenever some external or some energy is being applied to the semiconductor, so these electrons which are available in the valence band, they are able to actually overcome the band gap and they can move to the conduction band over here, right? So due to this, at times it behaves as a conducting material, at times it behaves as an insulating material, depending upon what is the underneath the situation is, right? So this is the basically the idea behind that of the conductor, insulator, and that of semiconductor, right? So I know that you people have already studied this thing, the conductors, insulators, semiconductors, but to go along, so we will have just a refresher course, which you have studied previously. Okay, so now when we take a look of the semiconductor, anyone having any question? कोई question हो तो you can ask me. Anybody?
No, sir.
Okay,
No, sir.
ठीक है जी. Okay, so when we take a look of semiconductor, so basically semiconductor, we have silicon. Silicon is being represented as Si, or we have another semiconductor which is germanium, right? So these are few which are mostly used, but out of this, silicon is widely used. Germanium is also used, right? Okay, so in case of the semiconductor, what we have in the outermost valence band, so we normally have 4 electrons. I think everybody knows about it. So what we have basically 4 electrons in its valence shell or valence band. And when we take a look of the crystal lattice of the silicon, so what is the situation that we have basically Si, we have Si, we have Si, we have Si, and we have Si, something like this. And what is happening that the outermost shell, they are making the covalent bonds, right? So they are making the covalent bond. Right? something like this, right? That every adjacent atom is actually participating in such a way that they are making the covalent bonds, right? Are you with me? If you can see, we have something like this, that they are making the covalent bonds over, right? So this is the pure semiconductor. Now, semiconductors are of two types when we take a look. So semiconductors are of two types. One is called the intrinsic semiconductor, and the other one is called extrinsic semiconductor, right? Now, what is the difference between intrinsic semiconductor and that of the extrinsic semiconductor? So intrinsic semiconductor is basically the pure semiconductor. Let's suppose like we take a look of the silicon lattice. So in that, there is no impurity which is being added, right? So when no impurity which is being added and it is in its purest form, so what we say that this is basically the intrinsic semiconductor, right? Now, when we take a look of intrinsic semiconductor, so in intrinsic semiconductor, we can have basically, because if you see as we have discussed that we have the valence band and we have the conduction band, right? So whenever we have the intrinsic semiconductor, and in the intrinsic semiconductor, we have basically, जी इनामुल्लाह, कुछ पूछना चाह रहे हैं?
नो सर, गलती से हो गया सर.
अच्छा, ठीक है. Okay. So whenever we have intrinsic semiconductor, so if some external heat or some energy is being applied, so what happens that the covalent bonds which are being made in the valence band, they can actually be taken out, and the electron which is there, it can actually move from the valence band and it can go into the conduction band, right? So, so whenever some external energy, or we can say some heat energy is being applied, so what happens that the electron which are available in the valence band, it can go into and it breaks the covalent bond, and the electron go into from the valence band, it goes into the conduction band, right? And when it goes into conduction band, so what happens that whenever electron leaves the valence band, so it creates a space over here, and the space over here is normally called the hole, right? So what happens that a hole is being created in the valence band, and the free electron is getting into the conduction band. So if I just show you that the situation is something, whenever some energy is being applied. So the situation is something like in the valence band. In the valence band, what happens that a hole is being created, and in the conduction band, we have the free electron. Right? In the conduction band. Right? In the conduction band, free electron is being provided and a hole is being created in the valence band. Now, this creation of electron hole pair is now the element through which in the intrinsic semiconductor, we can have some current that can flow. And how this can be done, that if we take this pure semiconductor, intrinsic semiconductor over here, right? So what we have, let's suppose we say we have this piece of intrinsic semiconductor. So this piece of intrinsic semiconductor can be, we have Si, 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 right? Si, we have Si, Si. These are silicon atoms, right? Silicon atoms. And with the silicon atoms, what we have, if we provide some biasing potential, means if we connect it with some positive and negative side of DC biasing source, means we are providing some DC biasing, or this means we are connecting it with some battery source, right? Now what will happen, that the electrons which are in the conduction band, as you can see, electrons, they are in the conduction band, and holes, they are in the valence band, right? So now, whenever this biasing potential is being applied, so this means this side is positive, this side is negative, right? Now, due to this positive, which is being applied, so the free electrons which are available in the conduction band, they will start moving towards the positive terminal. And due to that, what happens? A current will be generated, and that current is called the electron current, right? Are you with me?
Yes, sir.
Yes, sir.
So due to this, what happens, that a current will be generated, and that current is called the electron current, right? Now, this is the first current which is there due to the free electrons which are available in the conduction band. But what we have holes which are available in the valence band as well, right? If you can see, we have holes in the valence band. So this means we will have some holes and we will have some free electrons which are generated due to the electron hole pair, right? Now, when this potential is being applied, so it is not only being applied to the conduction band, but it is applied to the whole crystal lattice, which is of silicon, right? Now, due to that, what happens, that in the valence band, there is also going to be some effect of this. And what is the effect of this? That if you see, whenever the potential is being applied to the silicon, so the effect is, if you see, we have this silicon lattice. So whenever the potential is being applied across this, so the electrons which are there in the valence band, they are also being affected due to the application of the DC source. So what happens that one of the electron which get excited, so what it will do, it will try to move and leave its space from here, and it can go to occupy the hole which was being created previously, right? So this electron can move from its position to the hole which is available over here. So whenever the electron moves from here to the hole, so this means whenever the electron moves, so this means a hole is being created. Ji Shehzad, question.
सर लड़के इनवाइट भेज रहे हैं, उनको क्लास में अलाउ कर दें, काफी बहुत से
जो कर रहे हैं सबको अलाउ करती है.
ओके सर
जी. अच्छा. So whenever the electron in the valence band leaves its place and occupy the hole which was being created due to the electron hole pair creation. So now if you see the electron moves from here to here and the hole is moving in the opposite direction, right? So what is happening now, that the hole is moving in the opposite direction as that of the electron movement in the valence band. So due to that, there is another current which is flowing inside the valence band, and that current is called the hole current, right? So whenever we have the pure semiconductor over here, so one current is flowing in the conduction band, the other current is flowing in the valence band. So in the conduction band, the current which flows is called the electron current, right? And the current which flows in the valence band is called the hole current, which is due to the movement of the holes inside the valence band, right? Are you with me? Any question?
No, sir.
Excuse me, sir.
Ji.
Sir, holes are positive charges?
Holes are basically the void of electron, right? So void of electron means whenever there is no electron which is available, so this means a hole is created, right? बात समझ में आ रही है?
ओके सर, समझ आ गई.
सर होल पे तो मतलब पॉजिटिव चार्ज होता है ना?
होल देखें, जहां पे इलेक्ट्रॉन को होना चाहिए और इलेक्ट्रॉन मौजूद नहीं है, तो वो बेसिकली होल है. बात समझ में आई?
यस सर.
तो
सर इस पे हम विजिबल कह
उसको
सकते हैं कि इस पे पॉजिटिव चार्ज है या चार्ज नहीं है, न्यूट्रल है?
नहीं, हम उसको लेते पॉजिटिव चार्ज ही हैं, लेकिन मैं आपको समझा रहा हूं कि होल चीज क्या है. कि देखें, होल एक ऐसी चीज है कि आप उसे कहते होल क्यों है, कि इट इज वॉइड ऑफ इलेक्ट्रॉन, कि जहां पे इलेक्ट्रॉन को होना चाहिए था वो नहीं है, तो उसके ना होने की वजह से एक आप कहते हैं एक चीज बन जाती है जिसे हम होल कहते हैं, राइट? और इसका नाम भी देखें तो HOLE, अगर आप इसको गूगल करें तो इसका मतलब है ये एक खाली जगह है, राइट? It is void of electron. The definition is it is void of electron. Means that the electron should be there, but it is not present over here. So when it is not present over here, we call it a hole, right? Because electron itself has a negative charge. So when there is no negative charge which is available, so this means it is a positive charge. But this is the point that what is a hole? Hole is basically that whenever electron leaves its place, a hole is created.
सर, excuse me सर.
जी.
सर होल पे तो मतलब मास नहीं होता ना, होल का स्पेस होती है ना, तो मतलब चार्ज तो इसकी जो करेक्टर्स है वो मतलब हमेशा मास पे होता है चार्ज. तो होल का तो मास नहीं है, फिर उस पर चार्ज कैसे होता है सर?
तो यही तो मैं आपको बात बता रहा हूँ, इसीलिए तो मैंने आपको ये सारी कहानी सुना रहा हूँ। ठीक है, कि जब आप कहते हैं कि इलेक्ट्रॉन जहां पे मौजूद होना चाहिए था वो वहां पे मौजूद नहीं है, राइट? क्यों मौजूद नहीं है? क्योंकि उसने अपनी जगह छोड़ दी। जब उसने अपनी जगह छोड़ दी, सो उसकी जो जगह खाली बच गई उसको हम होल कहते हैं। लेकिन एज सच इलेक्ट्रॉन पे नेगेटिव चार्ज होता है, तो जब उसने अपनी जगह छोड़ दी तो मतलब वहां पे पॉजिटिव चार्ज, नेट पॉजिटिव चार्ज बन गया। नेट पॉजिटिव चार्ज किस तरह बन गया? क्योंकि आपको पता है जब भी कोई एटम होता है तो उसके पॉजिटिव और नेगेटिव चार्ज बराबर होते हैं, राइट? इज दिस थिंग क्लियर?
यस सर।
तो जब इलेक्ट्रॉन वहां से चला जाता है तो उस एटम पे नेट पॉजिटिव चार्ज आ जाता है, क्योंकि उस एटम ने एक इलेक्ट्रॉन लूज कर दिया। तो जब लूज कर दिया तो जो जगह बन गई, तो फिर हम कहेंगे कि ये पॉजिटिव चार्ज इस होल की वजह से आया है, राइट? बेसिकली वो
Yes, sir.
नेट आपने जो है प्लस माइनस करेंगे तो वो नेट, क्योंकि उसका जो पॉजिटिव चार्ज है वो ज्यादा होंगे नंबर पे, तो इस वजह से हम होल को कह देते हैं कि ये पॉजिटिव चार्ज है। हम अपनी मैथ्स को ठीक करने के लिए कह देते हैं। बात समझ में आ रही है?
जी सर।
ठीक है जी। तो एज सच होल पे पॉजिटिव चार्ज नहीं होता, लेकिन हमें क्योंकि उस चीज को थ्योरेटिकली एक्सप्लेन करने के लिए हम कहते हैं कि होल पे पॉजिटिव चार्ज है। अदरवाइज आपके जो है वो एटम का स्ट्रक्चर सही नहीं आएगा।
Yes, sir.
So now what is the situation that we have basically two currents. One is the current which is flowing in the conduction band, that is due to the free electrons, and one is the current which is flowing in the valence band due to the holes, right? And that current which is flowing due to the holes is called the hole current, right? Now this is the situation which is taking place in intrinsic semiconductor. Intrinsic semiconductor means we have not added any impurity in the pure semiconductor, right? Now, whenever, let's suppose we add any impurity means we can have basically the, if you see, so the extrinsic semiconductor is basically a semiconductor in which some other impurity is being added. So extrinsic semiconductors, they are of two types. One is called N-type, which you people have already studied, and then there is a P-type, right? Now, N-type semiconductor is the one in which we add an impurity which has 5 electrons in its outermost shell. Right? Now, we have different atoms which have got 5 electrons in its outermost shell. One is arsenic, phosphorus, bismuth, or antimony. Right? So let's see what happens when we add a pentavalent impurity. Pentavalent impurity means 5 electrons in its valence shell, right? So 5 electrons in its valence shell. So what happens that if we add a pentavalent impurity in a pure semiconductor, right? So again, we say that the pentavalent impurity is antimony. Antimony is having a symbol as Sp, and Sp has basically 5 electrons in its valence shell, right? Now what happens that if we add the antimony, now if we add a pentavalent impurity in the outermost shell. So what happens that, let's see, we have pentavalent impurity is Sp. Now Sp, with that we add in the silicon. Again we have silicon, and we have silicon, and again we have silicon, right? So the covalent bond, they are going to be made. So again we will have the covalent bond over here, covalent bond over here, covalent bond over here, covalent bond over here, over here, over here, over here, over here, and over here, right? So this means 4 covalent bonds will be made, but in the antimony we have 5 valence electrons. So this means there is 1 free electron which is now being left. And as this is a free electron which is being left, so this free electron is available in the conduction band, because this is basically a high moving electron. It cannot make a covalent bond, and due to that it goes into the conduction band, right? So depending upon the number of impurity atoms which are being added, so as much atoms which are being added, so we will have as much as free electrons they will be available in the conduction band due to the addition of the pentavalent impurity. And as well as we will have a very small number of holes which will be there due to the electron hole pair creation, which we have just seen in case of intrinsic semiconductor. And as we know that there are electron hole pair, so the number of the total electrons which will be available in the conduction band will be the number of electrons due to the added impurity plus the number of electrons due to the whole electron pair creation. So this means we will have few more over here due to the electron hole pair creation. Now this type of material which is being created with the pentavalent impurity is called N-type semiconductor, right? Okay, the session is going to end in less than a minute. We will restart in 5 minutes. Okay, so the electrons in N-type material are called majority carriers, and the holes in the N-type material, they are called minority carriers. Okay, ji? Okay, the session is going to end within few seconds. Within 5 minutes we will restart. ठीक है जी, सेशन एंड होने वाला है.